There are 3 important intermolecular forces we should know about. The first one is hydrogen bonding. The second one is dipole-dipole. And the third one is London dispersion forces. So, hydrogen bonding. Hydrogen bonding is the interaction between a hydrogen atom, which must be bonded to a fluorine, oxygen, and nitrogen atom, and another atom of either fluorine, oxygen, or nitrogen of another molecule. As you can see in these Lewis structures, which are of water, a very common household substance, the positively charged hydrogen atom is attracted to the negatively charged oxygen atom of another molecule, and that's what forms their extremely strong hydrogen bond. Next up, we have dipole-dipole interactions. Dipole-dipole interactions are what happen when positively and negatively charged ends of a polar molecule are attracted to other oppositely charged ends of other molecules. Our example here is hydrogen iodide. Hydrogen iodide is a polar molecule, and as indicated by the dipole moments here, the iodine is the most electronegative, which is where the most electrons are located, making it super negative, and where the positively charged H atom is attracted to the negatively charged I atom. Now, this sounds familiar to hydrogen bonding, which is actually a type of dipole-dipole interaction. However, for hydrogen bonding, you have to have specifically fluorine, oxygen, and nitrogen, which are the most electronegative elements, and the smallest atom, hydrogen, which makes the bond between the hydrogen and the fluorine, oxygen, or nitrogen much, much stronger than typical dipole interaction. So, you must be thinking, what about nonpolar molecules? These only seem to apply to polar molecules. Well, that's where London dispersion forces come in. London dispersion forces exist in everything. The electrons in a molecule form temporary dipoles, which allow for the dipole-dipole interactions to be recreated temporarily, allowing intermolecular forces to occur. LDF strength depends on 2 things. The most important one is polarizability. If a compound has more electrons and also more molar mass, it's more polarizable, and its London dispersion forces will be stronger. London dispersion forces are very weak compared to other intermolecular forces, so nonpolar molecules tend to have much weaker intermolecular forces. Our example here is methane. As you can see, there are temporary dipole moments which allow for the interactions to occur. Now, I know what you're thinking. This is cool and amazing, Sam, but why do I care, and how does this even apply to me? Well, proteins are an extremely important part of our lives, and their structures are mostly based on intermolecular forces. We have 4 kinds of structures for proteins: primary structures, secondary structures, tertiary structures, and quaternary structures. Secondary structures are the first ones to have hydrogen bonds, which is an intermolecular force, and it causes shapes like DNA to be created and held together, which is why knowing about proteins is so important and how their intermolecular forces function. Thank you for watching and have a nice day.